Assalamualaikum warahmatullahi wabarakatuh, and very good day to all of you. So for part number 3, we will discuss about the difference between two-stroke and also four-stroke engine, and then we will discuss also about the indicator diagram. First, we look at two-stroke engine, okay, in terms of mechanism. So before that, we look what we call a certain important point or important part in the two-stroke engine. So what I call the figure shows the schematic diagram of a two-stroke engine for spark ignition engine. So in the diagram we have 3 main port here. So we have exhaust port, where the port where we will release exhaust gas to surrounding. We have intake port, the port where we allow fuel plus air mixture enter to the engine, and we have transfer port, or we call for this chapter we call inlet port, the part where we allow the fuel plus air mixture enter the combustion chamber. And we have spark plug, the device that used to start the ignition and also the combustion process. So we have BDC, position, bottom dead center, and also top dead center, TDC. Okay, the upper part of the piston location, TDC, BDC, the lower part of the piston position. Okay, and also we have what I call the green region or green area represent the air fuel mixture. The grey area represent the exhaust gas, and the red area represent the combustion product during the combustion process. Okay, let's play what I call the animation of this two-stroke engine mechanism. Okay, before that, I want you to what I call during the animation process, I want you to identify or look at the movement of the piston. I want you to look at when the combustion occur, how the fuel plus air mixture enter the engine, and also how the fuel plus air enter the combustion chamber. And also you need to look at how the exhaust gas that produced from the combustion process release to surrounding. Okay, so now let's play the animation. Okay, you can look here the movement of the piston from BDC to TDC, okay, and also the rotation of the crankshaft. When the piston move upward, the piston will compress the fuel plus air mixture. Then the spark plug will produce spark in order to introduce the starting point for the combustion. When the combustion process occur, due to the high pressure, high temperature, the exhaust gas or the combustion product in the combustion chamber will push the piston downward, and then the exhaust gas from the combustion will release to surrounding through the exhaust port. Okay, that's how the mechanism of the two-stroke engine. So you need to know the process in terms of the mechanism of the two-stroke engine in order to understand the difference between two-stroke and also four-stroke. Okay, clearly we can see the fuel plus air mixture enter the intake port when the piston move upward, and then when the piston move downward, arrive at BDC, when the what I call the transfer port or inlet port open, the fuel plus air mixture will enter the combustion chamber. At the same time, this fuel plus air mixture flow will force the exhaust gas to release to surrounding through the exhaust port. Okay, so that's how the process of the two-stroke engine. Okay, so that's all in terms of mechanism of the two-stroke engine. Okay, now we look at the processes involved in two-stroke engine. So we go into detail in terms of thermodynamic process by referring to the PV diagram and so on. Okay, first this is what I call the schematic diagram, cross-section drawing for the two-stroke engine. So we have the important part in the schematic diagram, such as spark plug, cooling fin, piston, inlet port or transfer port, crankcase, crankshaft, connecting rod, intake port, exhaust port, and also cylinder head. So in the figure also, so we have what I call the position for BDC and also position for TDC. Okay, so now in order to describe the process inside the combustion chamber, we need to use the PV diagram, pressure versus volume. And this PV diagram, actually the PV diagram for the actual cycle for the two-stroke engine, for spark ignition engine. So in this diagram we have a few processes involved, such as compression, combustion process, expansion, and also exhaust process. Okay, and in the diagram also, the diagram indicate few important point where we have exhaust open point, inlet open point, inlet close point, exhaust close point, and also ignition point, the point where we call the starting point of the combustion process. Okay, and also if you look at the volume axis, so the graph also, or the diagram also indicate the position of TDC and also BDC in terms of volume. Okay, now in order to explain the process, we need to refer to this schematic diagram of this two-stroke engine, the movement of the piston, and simultaneously we also need to refer to the PV diagram, okay, to understand the process. Okay, so you need to focus few on the different ports, such as exhaust port, inlet port or transfer port, and also the intake port, in order to understand the explanation. Okay, now we look at figure A. So figure A shows the what I call the two-stroke engine process, where at this point the position of the piston is at BDC and the piston start to move upward. Okay, so the red area represent the exhaust gas and the yellow area represent the fuel plus air mixture. Okay, so during the process, if you look at the exhaust port is fully open, inlet port also fully open, however the intake port is fully closed. So in this process, the fuel plus air mixture in the crankcase will enter the combustion chamber through the inlet port, and at the same time this flow, fuel plus air mixture flow, will force the remaining exhaust gas to surrounding through the exhaust port. Okay, so now if you look at PV diagram, the process represented by point A, where the location in terms of volume is at BDC. Okay, is at BDC. Okay, next for figure B, the piston already move upward close to TDC. So we can see that the blue color area represent the what I call the compressed fuel plus air mixture. Okay, so because at this time the exhaust port is fully closed, inlet port also fully closed, where for exhaust port we will not allow any what I call gas or exhaust gas released to surrounding, and also will not allow any fuel plus air mixture enter the combustion chamber. However, during the process, because the intake port open, the fresh fuel plus air will enter the crankcase. Okay, as shown in the figure. So in terms of pressure and also temperature, the air fuel mixture in terms of pressure will increase, the temperature also will increase due to the compression process, where the piston compress the fuel plus air mixture inside the combustion chamber. Okay, so if we look at the PV diagram, the process described by point B, where the location of the point B is after the inlet port close point and also exhaust close point, as shown in the PV diagram. Okay, now figure C represent the process when the piston already arrived at TDC. Okay, so slightly before the piston arrive at TDC, the plug will produce spark in order to initiate the combustion process and produce commercial product that represented by red area in the figure. Okay, so during the process also, the exhaust port close, the inlet port also close to the refer to the what I call the opening for the combustion chamber, and intake port also open. Okay, so for this case, no exhaust gas or combustion product released surrounding, no fuel plus air mixture enter the combustion chamber. However, the fresh fuel plus air mixture will fill in throughout the crankcase. Okay, and stand by to enter the combustion chamber when the inlet port open to the combustion chamber area. Okay, so if we put the process, or refer the process on the PV diagram, so the process will represent by point C in the PV diagram, just after the ignition process, and at this point the volume is constant at TDC. Okay, and we can see that from the graph, the drastic increase during the process, drastic increase of pressure, and also the drastic increase of temperature. Okay, figure D shows the what we call the piston movement start to move downward due to the high pressure and also high temperature after the combustion process from TDC. So the piston will move downward, and still at this point, exhaust port close, inlet port also close, based on the call the area for the combustion chamber, and at this point the intake port also open. But for this case, because the piston already start to move downward, so no additional fresh fuel plus air mixture enter the crankcase. So in the crankcase, the area already fulfilled by the fresh fuel plus air mixture. Okay, so if you look at the PV diagram, so the estimated point is referred to the point D, and the pressure still increase. However, the internal volume start to decrease because the piston already start to move downward. Okay, the volume start to increase. Okay, so after this, the what I call the pressure during the movement of the piston downward will increase, and the pressure also will decrease. Okay, due to the expansion process. Okay. Okay, now figure E, the piston already moved downward, approaching the BDC location. So now the expansion process occur, the pressure value decrease, the volume of the combustion chamber increase. So at this point, we can see that the exhaust port open, the inlet port still closed. Okay, the intake port also closed. So you can see that due to the open, the what called the exhaust port is open. So now the combustion product or exhaust gas will release to surrounding through the exhaust port. Okay, so the fuel inside the crankcase will have the increase of pressure due to the close of intake port opening, and also the close of the inlet port. So because the movement of the what we call the piston downward, and also the rotation of crankshaft. The pressure of the fuel plus air mixture will increase and stand by to enter the combustion chamber. Okay, so if we plot the point for figure E on the PV diagram, the point will be represented by point E, and the location is in between the exhaust open point and also the inlet open point. Okay, so now the final figure shows the what I call the piston already arrive at the BDC position, and the inlet port already open, intake port closed, and exhaust port still open. So due to the high pressure inside the crankcase, so the movement of the piston downward and also the rotational movement of the crankshaft will force the fuel plus air mixture to enter the combustion chamber. Okay, and the flow of the fuel plus air mixture also will push the remaining exhaust gas released to surrounding through the exhaust port. Okay, now if we plot the point on the PV diagram, so we have point F, where point F actually equal to point A. Okay, so now why we call this engine as two-stroke engine? First, if we simplify the process, after we consider the air standard assumption, we will have simplified PV diagram for the ideal cycle as shown in the figure. So we have in the figure for the ideal cycle, we have only 4 state or 4 point involved and 4 processes involved. So we have state number 1, state number 2, state number 3, state number 4, where we have from state number 1 to state number 2, we have the compression process, where the volume decrease, the pressure slightly increase. And from state number 2 to state number 3, we have combustion process, where the pressure drastically increase due to the combustion process. And then the process from state number 3 to state number 4 represent the expansion process, where the pressure decrease, the volume increase. And the last one, the process involved is exhaust process. Start from state number 4 to state number 1 is constant volume at BDC. Okay, the pressure continuously reduced to close to atmospheric pressure. Okay, so now if we compare the ideal cycle of ideal PV diagram and also the schematic diagram, state number 1 represented by figure A, state number 2 represented by figure C, and this involves one stroke from BDC to TDC. Okay, and the process we call compression stroke. And state number 3 represented by figure D, and state number 4 represented by figure F. And this also will involve one stroke, and the stroke we call power stroke. So overall, for one cycle for this engine only consists of 2 strokes. First we have compression stroke, and the second one we have power stroke. So that's why we call this engine as two-stroke engine. Okay, I hope you can understand the process, the detail of the process, and also the mechanism of the two-stroke engine. In order, later on we want to differentiate between two-stroke engine and also four-stroke engine. Okay, now it's about the exercise for two-stroke engine. So now what I want you to do, first, based on the PV diagram, I want you to identify the point on the PV diagram that describe the process for figure A to figure F. For example, we have figure A, figure B, figure C, figure D, figure E, and also figure F. So for each figure, I want you to identify the exact or estimated point on the PV diagram for each individual figure. So if you can do this, if you can identify the point correctly for each figure, so I think you already understand about the two-stroke engine in terms of mechanism also processes involved with the two-stroke engine. Okay. Okay, now we discuss about the four-stroke engine mechanism. So now I hope you try to try to identify the difference between the four-stroke engine mechanism and also the two-stroke engine mechanism. Okay, so now let's look at the important component for this engine. So we have spark plug, which means the mechanism that I will explain is the four-stroke engine for the spark ignition engine. So we have cylinder, piston, intake valve, exhaust valve. We have the position for bottom dead center, the position for top dead center, TDC, top dead center, BDC, bottom dead center. And in this explanation, I will use blue color circle that represent the fuel plus air mixture, and red color circle to represent the exhaust gas or combustion product. In order to discuss or to describe the process, so what happened inside the combustion chamber in terms of pressure change and also volume change, we need to refer to the PV diagram as shown in the slide. So this PV diagram shows the actual thermodynamic cycle for four-stroke engine. Okay, as shown in the PV diagram, we can see four different important processes involved, such as expansion process, compression process, exhaust process, and also intake process, which each process I call represent the process for different stroke during the combustion process for the four-stroke engine. And on in the PV diagram also state about the few important points, such as the intake valve open point, exhaust valve open point, and the ignition point, and also end of combustion point. Okay, so if you look near to the exhaust process and also intake process, we have a line that indicate the value of atmospheric pressure, which means the exhaust process will have interval pressure inside the combustion chamber will have slightly higher than atmospheric pressure. However, during the intake process, the pressure inside the combustion chamber will be slightly lower than atmospheric pressure. Okay, now let's start with the mechanism of the four-stroke engine. So we start with the position of the piston at BDC, and the compression process will occur where at the beginning we consider inside the combustion chamber will have full of fuel plus air mixture inside the combustion chamber. Okay, so for the compression process, the piston must move upward, okay, as shown in the animation. Okay, so the piston will compress the fuel plus air mixture. So during this process, in order to conduct the compression process, the intake valve and also the exhaust valve must close. Both valves must close, so that the piston can compress the fuel plus air mixture. That's why during the process, if you look at PV diagram, the pressure increase and also the volume of the combustion chamber decrease. Okay, so the piston at this point will reach very close to TDC position. Okay, so next process is ignition process, the condition where in terms of position of the piston is slightly lower than TDC. So the spark plug will introduce spark in order to start the combustion process. Okay, so when the combustion process occur, the pressure and also the temperature in the combustion chamber will increase drastically, as shown in the PV diagram. Okay, so the piston will keep move until the piston reach to TDC. Okay, at the end of the combustion process, the position of the piston actually slightly lower than the TDC, where at that point the volume already decrease because the piston start to move. The volume already start to increase because the piston start to move downward for the expansion process. Okay, for the expansion process, the piston must move downward. So during the process, the volume increase, the pressure inside the combustion chamber will decrease, and the I call the substance inside the combustion chamber during this process is the combustion product or exhaust gas that represented by red color circle. Okay, so during the process also both intake valve and also exhaust valve are closed. Okay, next, in order to remove the exhaust gas or combustion product from the combustion chamber, so the piston must move upward in order to push the exhaust gas to remove the exhaust gas from the combustion chamber and to release it to the surrounding. Okay, so for the process, the exhaust valve must open, okay, to allow the exhaust gas that release to surrounding. Okay, if not, the gas will stay in the combustion chamber. Okay, so after exhaust valve open, the piston will move upward. The exhaust process will occur where the piston will force the exhaust gas release to surrounding. Okay, release to surrounding. Okay, as I mentioned before, the pressure during this process slightly higher than the atmospheric pressure. Okay, now in order to continue the process, for the combustion process, we need to have new fuel plus air mixture to enter the combustion chamber. So for this case, the intake valve must open. However, the exhaust valve must be closed before we open the intake valve. Okay, so when intake valve open, we already allow the fresh fuel plus air mixture enter the combustion chamber. Okay, so in order to suck as much as possible the fuel plus air mixture to enter the combustion chamber, the piston must move downward for the intake process. Okay, so the piston must move downward to BDC and suck the fuel plus air mixture to enter the combustion chamber. So this process we call intake process, and the pressure during this time is slightly lower than atmospheric pressure. Okay, so the process must continue for the next process, which is the compression process. So in order to compression process to occur, both intake valve and also exhaust valve must close. Okay, then the process continue. The piston move upward to compress the fuel plus air mixture again, and the ignition occur. The combustion process will occur again. So the process will keep repeating for the whole involved with the process in the engine. So the process will continue in the cycle. Okay, in the cycle. So that's how we explain about the four-stroke engine mechanism. So now I hope you can differentiate or identify the difference between four-stroke engine and also two-stroke engine in terms of mechanism. Okay, now we discuss in detail about the processes involved for four-stroke engine. Okay, so first the schematic diagram shows the cross-section drawing for the four-stroke spark ignition engine. So we have important parts such as inlet cam, plug, spark plug, exhaust cam, valve, intake valve, exhaust valve, piston, connecting rod, crankshaft, water jacket, and so on. Okay, so in order to describe, as I mentioned before, in order to describe what happened inside the combustion chamber for the four-stroke engine in terms of pressure change and also volume change, we need to refer to the PV diagram. And the first PV diagram shown in the slide is for the actual thermodynamic cycle for four-stroke engine, where the process we already discussed when we discussed about the mechanism for four-stroke engine. Okay, So now if we look again in term of the process involved in 4-stroke engine, let's say we want to know why we call this engine as 4-stroke engine. Okay, so now we look at figure A. So in terms of what we call the process involved, we have figure A where the piston at BDC and the substance inside the cylinder is the fuel plus air mixture that represented by yellow color area. And figure B shows the figures or the position when the piston move at TDC for the compression process. So now the piston compress the fuel plus air mixture inside the combustion chamber. Okay, after piston arrive at TDC or before TDC, the spark plug will introduce spark and the combustion process will occur. Okay, so next in figure C, after the combustion process occur, the combustion will produce a combustion product that represented by red color area, and due to the high pressure, high temperature, and the process will produce power, the exhaust gas or combustion product will push the piston downward from TDC to BDC, and the process will involve expansion process. Okay, as shown in figure D, where the piston arrive at BDC, and during I call the process involves figure A, figure B, figure C, and also figure D. The process in terms of valve, both intake valve and also exhaust valve are closed. So during the process, okay, both valves are closed during the process. Okay, now because inside the combustion chamber we actually full with the combustion product or exhaust gas. So in order to remove this gas, we need to open the exhaust valve, and we need to allow the piston move upward, and the piston will push this gas to release to the surrounding. Okay, as shown by figure E. Okay, so the piston start move from BDC and move upward until the piston reach at TDC, as shown in figure F. The exhaust valve still open, and the remaining exhaust gas will be released to surrounding. Okay, so next, after all the exhaust gas released to surrounding, so the process must continue. So we need to have what I call the fresh fuel plus air mixture into the combustion chamber. So we need to close the exhaust valve and open the intake valve in order to allow fuel plus air enter the combustion chamber. So at this point, the position of the piston is at TDC. Okay, next, in order to suck the fuel plus air into the combustion chamber, so we need to the piston must move downward and suck the air plus fuel enter the combustion chamber. Okay, so the process will involve intake process. Okay, so now we have 4 different processes. For figure A and figure B, we have compression process. Okay, figure C and figure D, we have the expansion process. Figure E and F represent the exhaust process, and figure G and figure H represent the intake process. Okay, so we have 4 processes, and each processes will involve one stroke, because the distance between BDC, because the process involve the distance between BDC and also TDC. Okay, so the schematic diagram we already simplified in order to easy to understand the processes involved in the 4-stroke engine. So now, in terms of PV diagram, if we simplify the PV diagram after we consider S and assumption, so the process will be PV diagram for the ideal process, as shown in the second PV diagram. So in the PV diagram, we have 5 states involved, state number 1 until state number 5. Okay, So state number 1 to state number 2 represent the compression process. State number 2 to state number 3 represent the heat addition process or combustion process. State number 3 to state number 4 represent the expansion process. State number 4 to state number 1 represent the heat release process. And state number 1 to state number 5 represent the exhaust process. The last one, state number 5 to state number 1, represent the intake process. Okay, so this PV diagram we already simplified, so we get this kind of shape for the thermodynamic cycle for the ideal 4-stroke engine cycle. Okay, so now if we relate, so because we want to know why we call this engine as 4-stroke, so try to relate the state inside the in the PV diagram with the figure schematic diagram. Start from figure A to figure H. So figure A actually represent the state number 1 in the ideal PV diagram, and figure B represent the state number 2, and this process that involves state number 1 to state number 2 we call the compression stroke. Okay, the process involves 1 stroke, and the process also involve the compression process, so we call compression stroke. However, figure C represents state number 3, figure D represents state number 4, and also the process involving state number 3 to state number 4 also involve 1 stroke, and because during the process involved is expansion and produce power during the process after the combustion, the process will involve what I call will produce power. So this process we call power stroke. Okay, and the process also involve 1 stroke from TDC to BDC. Okay, next figure E represents state number 1, figure F represents state number 5, and we call the process equal to the exhaust process. And because exhaust process, because the process also involves 1 stroke in terms of the movement of the piston from BDC to TDC, so we call the process as the exhaust stroke. The last one for figure H represents state number 5, figure G represents state number 5, and figure H represents state number 1, and we call the intake stroke because it involves intake process, and the distance in terms of piston movement involved with 1 stroke from TDC to TDC. So overall in one cycle we will have 4 stroke: compression stroke, power stroke, exhaust stroke, and also intake stroke. So that's why we call this kind of engine as 4-stroke engine. Okay, so I hope you can understand the process and also the mechanism involving 4-stroke, and you can differentiate between 2-stroke engine and also 4-stroke engine. Okay, now exercise for 4-stroke engine. So based on the PV diagram for the 4-stroke engine, so I want you to identify the point on the PV diagram that describe the process for each figure from figure A to figure H. So for example, if you have figure A as shown in the slide, so you need to identify the process, I call the process, and represent the process by identify the point on the PV diagram. Okay, so we have figure A until figure H. So this is figure B, figure C, figure D, figure E, figure F, figure H, and also figure G, and also figure H. Okay, so I will let you to identify for different figure with different point on the PV diagram. So if you can do and get the correct point on the PV diagram, so you already understand the process and also the mechanism for the 4-stroke engine. Okay, next we will discuss about the indicator diagram. What is the meaning of indicator diagram and what is the function of indicator diagram? Okay, indicator diagram. Indicator diagram actually same as the PV diagram. So we can say that the other names for PV diagram is indicator diagram. Okay, So this indicator diagram actually we will use to describe the process inside the combustor chamber in terms of pressure change and also volume change. So if you look in this PV diagram, so this PV diagram represents the actual cycle for 4-stroke engine, and we have two different loops in this PV diagram. First, we have power loops, okay, that consists of expansion curve and also compression curve. The second loop we call pumping loop, that involves with that consists of exhaust curve and also intake curve. Okay, for power loops, in terms of definition, actually refer to the area enclosed by the compression and also expansion curve. And the value in terms of area that enclosed by the compression and also expansion curve represent the net work done on the piston by the gas. Okay. However, for the pumping loop, in terms of definition, is the area enclosed by the exhaust and also the intake curve, and the value will represent the net work done by the piston on the gas. Okay. So the area under the curve for PV diagram actually gives the value of work done for the specific processes. For example, if we calculate the area under the curve for the compression curve, we will get the value for work done by the piston on the gas. Okay, so the value will be work done during the compression process when the piston move upward and the piston compress the fuel plus air mixture inside the combustor chamber. And if we calculate the area under the curve for the expansion curve, so we will get the value for work done on the piston by the gas. Okay, so this process will refer the process during the expansion process, because the high pressure, high temperature, the gas will push the piston downward. Okay. Okay, so now we have another parameter to describe what we call in terms of performance and also the properties of the engine, that we call MEP, mean effective pressure. The value will be the formula will be MEP, mean effective pressure, equal to W net divided by V max minus V min, equal to W net divided by V max minus V min. Okay, so we have two different equations. First equation involves with kilojoule unit, the second one involves with kilojoule per kg unit. Okay, so this parameter MEP actually is a pressure that if it acts on the piston during the entire power stroke would produce the same amount of net work as that produced during the actual cycle. So we can use this parameter to compare the performance of reciprocating engine of equal size. Okay. Okay, for example, the usage of MEP parameter. For example, we have two types of engine. We want to know which one is better. For example, we have engine A. The engine use biodiesel as its fuel, and the bore size is 15.5 cm, and this engine produce W net 510 kJ. However, the second engine, the engine use diesel fuel, and the size of engine bore equal to 15.7 cm, and this engine produce W net equal to 505 kJ. So if you look to both engine, so we can see that quite similar in terms of size, and the W net output also quite similar, more or less equal. So if you want to know which one is better, we need to calculate MEP value to determine whether engine A or engine B is better. So the higher value of MEP will determine that the engine will have better performance. Okay, so I will let you to calculate the value of MEP and then determine which engine is better, whether engine A or engine B. Okay, so that's all for part number 3.